common denominator. So I'm going to change this 1 into a common denominator with the cos squared theta. So this is sine squared theta over cos squared theta plus cos squared theta over cos squared theta. And now that they have a common denominator, I can write the numerator over 1 denominator. Okay, just combine the numerator. And now I'm going to analyze for Pythagorean identity. I could have done it early, but I didn't see anything. I mean, I saw the sine squared theta plus 1 over here, and that was kind of piquing my interest. But now that I collected the common denominator, I see for sure that this up here, this is just Pythagorean identity. So I'm converting that to a 1. And this is 1 over cos squared theta. Actually, I'm going to erase that because I don't like changing one side if I don't have to. I'm going to go over here, and I'm going to go 1 over cos squared theta is secant, and this equals the right side. Therefore, the identity is true. Okay, so here we have a bit of a more complicated example because we have fractions on both sides and we have a binomial in each one of those fractions. So which side is more complicated? So I'm going to tell you which side is more complicated with my reasoning. So if you encounter something like this, you will know. The right side is more complicated. Why? Because the binomial is in the denominator. When stuff is complicated at the bottom of a fraction, it is way harder than if it's complicated at the top of the fraction. Okay, so when you're looking for complications, we look for those complicated denominators in fractions. Now, this is going to be the first time you see multiplying by the conjugate, and I'm going to tell you what to do. When you have something complicated at the bottom, there's nothing I can change 1 plus cos theta into that helps me with my identities. Okay, so I use a process called multiplying by the conjugate, and this is what this is. So I rewrite the fraction, and I multiply it by something that is the value of 1 that doesn't change this fraction, but it is the opposite of the denominator. So all I have to do is rewrite the denominator, but change the sign. 1 minus cos theta over 1 minus cos theta. So it's the exact same as the denominator, except it's over itself and it's subtraction. Now, why do we do this? We do this because the denominators multiplying by each other here are something that we're interested in, and we've learned is this difference of squares. And difference of squares helps us get a square cosine. Okay, and square cosines help us with Pythagorean identity. It helps us with other things too, but we're really interested in this difference of squares. So the top's going to be pretty straightforward. Sine theta 1 minus cos theta over 1 minus cos squared theta equals. Okay, so I just use difference of squares to multiply these two things together, and I'm done over there. Okay, now next I'm looking at the bottom here, and this is part of my Pythagorean identity, right? So Pythagorean identity is sine squared theta plus cos squared theta equals 1. But if I bring that cos over, remember I told you sine squared theta is 1 minus cos squared theta. So I'm going to convert this 1 minus cos squared theta. I'm going to keep the numerator the same, and I'm going to change it to sine squared theta. Okay, I'm going to erase this side. Okay, now these signs, one of them cancels out. This is like saying x over x squared. So over here, I lose the sign on top, so I have 1 minus cos theta, and I'm left with 1 sine on the bottom, because one of the x's technically canceled out, x over x squared. Okay, so I'm still left with an x at the bottom. So it's hard to see initially when we're talking about sine squared and regular sines. To see that is difficult. It's probably the hardest part of 4.6. But once we get over that hump, everything will clear up. Okay, now, I'm looking at this. I look at the question. This is the right side. I'm done. Therefore, the identity is true. Okay, so for those guys who are really confused right now, what is going on? This is not a process that is the same for everyone. This is not math that you can look at this example and apply it to another example. These are just general tips to get through this to reach your destination. Your destination is the right side of the equation. So when in doubt, you have to do something. If this doesn't look like this, do something to it. Whatever it is, anything mathematically correct will work. Now, with experience, you will slowly learn what to do that will get you to your answer in the fewest number of steps with the smallest amount of error. And that's what trig identities is. It's you problem solving and trying to take the shortest route to the answer. This is math in general.